Hi, I'm Patty. I'm going to lead you through this unit orientation video for rock transformations, the second sixth grade core unit for Fayette County. In rock transformations, students take on the role of student geologists as they investigate different ways rocks form and change as they try to solve a geologic puzzle. Students are challenged to figure out how two rock samples, one from the Great Plains and one from the Rocky Mountains, look very different but are composed of a surprisingly similar mix of minerals. Did the rocks form together and get split apart, or did one rock form first and then the other rock formed from the materials of the first rock? Students work to solve this mystery, learning much about how rocks form and transform, driven by different energy sources. All Amplify Science core units, grades 6 through 8, can be conceptualized with the following structure. At the beginning of the unit, students are introduced to a phenomena and the related problem. The students then spend the majority of the unit collecting information from multiple sources and leveraging the multiple modalities of doing, talking, reading, writing, and visualizing. As students gather more and more information, they're able to apply what they've figured out to explain the phenomenon, and this process is iterative. So as they collect the information from multiple sources using multiple modalities, their explanations become increasingly more complex throughout the unit. Core units have 4 chapters. The first 3 chapters focus on the anchor phenomenon. By the end of Chapter 3, students use evidence to explain how the Great Plains and Rocky Mountains could have transformed, modeling the transformation with a paper modeling tool. Students support a claim about why the Great Plains and Rocky Mountains have similar mineral compositions. And in the 4th and final chapter, they're introduced to a new real-world phenomenon that is distinct but related to the anchor phenomenon of the unit. Well, that's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter and every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students investigate and learn that rocks that form in different ways are different types of rock. Key evidence sources include information gained from observations and visualizations. Students explore to learn about different ways rocks form in the sim, and they collect data as they watch a short video. At the end of Chapter 1, students return and apply these ideas to the anchor phenomenon. They explain that the rock of the Great Plains is sedimentary rock, and the rock of the Rocky Mountains is igneous rock. They formed in different ways, so they must not have formed together. Rocks can form in different ways, which causes them to be different types of rocks. When sediment is compacted and cemented together, it forms sedimentary rock. When magma cools, it hardens to form igneous rock. In Chapter 2, students learn that material for rock formations can come from rock formations that are weathered or melted. In this chapter, students read an article, Devil's Tower, and they use information from various media to write about how energy affects rocks using unit vocabulary. At the end of Chapter 2, students are able to explain that it's possible that the Great Plains formed from sediment that eroded off the Rocky Mountains. It might also be possible that the rock of the Rocky Mountains formed from the rock of the Great Plains. If Great Plains rocks were somehow carried underground, the energy from the Earth's interior could melt it into magma. Matter gets transformed by energy, but the same matter is still present. Sediment forms when any type of rock is weathered, a process driven by energy from the sun. Magma forms when any type of rock is melted. a process driven by energy from the Earth's interior. In Chapter 3, students investigate and find out that rock formations can move between the Earth's surface and its interior, which can lead to their transformation. Students revisit the sim to transform rock using plate motion and discuss and write about how plate motion exposes rock formation to energy sources. They write a final report, making a claim and supporting it with evidence about how this transformation could have occurred and how the two areas could have similar mineral composition. At the end of Chapter 3, students are able to explain that the plate motion that occurred near the Great Plains and the Rocky Mountains uplifted igneous rock that formed underground. This rock eventually eroded, and its segment formed sedimentary rock in the Great Plains. Plate motion moves rock formations. Subduction moves rock down below Earth's outer layer. Uplift moves rock upward towards Earth's surface. Uplift and subduction can expose rock formations to different energy sources, which can transform them. Any type of rock can transform into any type of rock because of plate motion. In Chapter 4, students apply their understanding of the key concepts to a new problem to try to explain what rock transformation processes are happening on Venus. They examine evidence and evaluate the quality of evidence as they compare the rock on Earth and Venus. They analyze and sort evidence based on claims, participating in a science seminar, and writing a final argument to support their claim. As you are getting ready to start rock transformations, some of these unit resources will really be helpful in getting an overview of the unit. The unit map shows you what students figure out and how they learn it chapter by chapter. Also on the unit landing page, you'll find articles in the unit and apps in this unit documents, which will provide more details on the unit reading and digital tools. The Coherence Flowchart is a favorite go-to resource to see the intended learning and how students unwrap the unit phenomenon chapter by chapter. The 3D statements will give you descriptions of how Amplify Science meets the 3 dimensions of the NGSS in every lesson and chapter. I hope you're feeling excited to start teaching this unit. In addition to resources on the Amplify platform, check out the at-home videos and at-home unit to help you teach the unit remotely. You can use any combination of these resources to engage your students in figuring out about rock transformations. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you.